In this video we will discuss the area of a trapezium and area of a general quadrilateral. You already know from your previous classes that the area measures how much space a shape covers, and perimeter is the outline distance around it. Just like when you're laying out a picture frame. The glass inside is the area, while the frame itself is the perimeter. Before starting with the main topics of the video, let's see a quick recap of some common shapes and their areas and perimeter. In rectangles, area is equal to length times width and perimeter is equal to sum of all sides. For squares, since all sides are equal, area is equal to side square and perimeter is equal to 4 times side. In circles, here, the area is equal to pi r squared, where pi is approximately 3.14 and r is the radius of the circle, and the circumference is equal to 2 pi r. In triangles, area is equal to half times base times height. For parallelograms, area is equal to base times height. Got all that? Great! You're already familiar with these concepts. So let's start something new. Have you ever seen a trapezium? A trapezium is like a rectangle with one corner cut off, creating a slanted side. This is done by removing a triangle from one corner of the rectangle, parallel to its base. Books will tell you that the area of trapezium is half the sum of the parallel sides times the height. But how did we derive this formula? Let's see for ourselves using an example. Meet Najma, who has a beautiful plot of land. She wants to cover her plot of land with grass, but there is one problem. Unlike the rectangular plots in her neighborhood, Najma's plot looks different because it has just one pair of parallel sides, making it a trapezium. And she does not know how to find its area. To find out how much space Najma's plot covers, let's first label the corners of her plot as ABDE. We will first draw a line EC parallel to the side AB. This clever move splits the plot into two familiar shapes, a rectangle ABCE and a right-angled triangle ECD. Remember, the area of a rectangle is length times width, and the area of a triangle is half times base times height. Let's use these formulas to find the area for Najma's plot. Step 1. Calculate the area of triangle ECD. For the triangle, we use the formula half times base times height. Here, the base C is 10 meters and the height H is 12 meters. So, the area of triangle ECD is half times 10 times 12 is equal to 60 meters square. Step 2. Calculate the area of rectangle ABCE. Now, for the rectangle ABCE, the formula is length times width. The length A is 20 meters, and the width H is also 12 meters. Thus, the area of the rectangle is 20 times 12 is equal to 240 meters squared. By combining the area of the triangle and the rectangle, Najma finds that her plot covers 60 meters squared plus 240 meters squared is equal to 300 meters squared of space. That's the size of her trapezium-shaped plot. We can also write the area by combining the two areas and write the area of trapezium ABDE is equal to half times H times C plus H times A, which can be resolved further as shown in these steps. Now, from the figure, we can see that A plus C is equal to B, so we can write the formula as area of trapezium is equal to H times A plus B divided by 2. Or sum of parallel sides times height divided by 2. Again, by substituting the values of H, B and A in this expression, we find the area is equal to 300 meters squared. And there you have it. We have calculated the area of trapezium field plot using the derived formula. Now let us see how do we calculate the area of a general quadrilateral. Unlike the shapes we've met before, this one doesn't have sides, which we can easily measure to find its area. But don't worry, with a bit of work, we can solve this as well. Here we have taken a general quadrilateral ABCD. Now let's see how to calculate its area. Step 1. Use of the diagonal. Join the points A and C making the diagonal AC. This line splits our quadrilateral into two triangles, ABC and ADC. This diagonal will pave the way for us to calculate the area of our quadrilateral. Step 2. Calculating the area of triangles. Recall students, the area of a triangle is half the base times the height. Our base for both triangles is the diagonal AC. Let's call the heights from the base to the opposite vertices H1 for triangle ABC and H2 for triangle ADC. Step 3. Adding up the areas. To uncover the total area of our quadrilateral, we simply add the areas of our two triangles. That's half times AC times H1 for the first triangle plus half times AC times H2 for the second. Adding them up gives us half times AC times H1 plus H2. Finally, we have got the area formula, so the area of our quadrilateral ABCD is half times D times H1 plus H2, where D is the length of our diagonal AC, and H1 and H2 are the heights to this diagonal from the opposite vertices. Let's try to solve an example using this formula. The diagonal of a quadrilateral-shaped field is 24 meters and the perpendiculars dropped on it from the remaining opposite vertices are 8 meters and 13 meters. Find the area of the field. Let us first draw a figure for this question. Now, from the figure we can see that H1 is equal to 13 meters, H2 is equal to 8 meters, and the diagonal, D is equal to 24 meters. Now putting these values in the formula that we derived previously, we get that area of quadrilateral is equal to half times 24 times 13 plus 8 is equal to half times 24 times 21 is equal to 252 meters squared. So, the area of our quadrilateral shaped field is 252 meters squared. Let us now have a brief recap of what we have studied so far. We revisited fundamental shapes, reviewing their respective areas and perimeters. Subsequently, we delved into deriving the formula for calculating the area of a trapezium. Additionally, we explored methods for determining the area of a quadrilateral and derived its formula. To discover more about such topics, check out the EduRev app. It offers video lessons, chapter summaries, and quizzes designed to help you understand these concepts better. You can also find engaging courses on subjects like science, social studies, English, Hindi, and more.